The place looks different now. Boca Chica used to feel empty and quiet. Today it feels busy and loud. Steel towers stand where sand once sat. Big cranes swing day and night. You can see 2 launch pads from one road. That sight tells you something changed. SpaceX did not stop at 1 pad. They built 5. 2 in Texas, 3 in Florida. That move matters more than it sounds. You already know why. 1 pad limits everything. 5 pads change the game. You felt this before in other industries. 1 factory can't meet demand. 2 helps, 5 changes who controls the market. That's the shift happening here. Starship is not a single rocket plan. It's an entire system. Pads are part of that system, and pads decide pace. Pace decides winners. You already know that speed is the only thing that beats big money. These pads are the engine of that speed. The first 2 pads sit at Starbase in Texas. They sit only a few hundred yards apart. Pad A came first. People call it OLP-1. That pad handled the earliest orbital flights. It took the heat. It took the damage. It taught the lessons. Engines hit it with over 16 million pounds of push. That's like stacking over 2,300 loaded dump trucks on one spot. The concrete did not like that. Neither did the steel. Debris flew. Water systems failed. Flame bounced back up. That pain forced change. Engineers tore parts out. They cut into concrete. They rebuilt steel. They added a flame trench. That trench gives fire a path. Fire always finds one anyway. This time it's guided. It keeps the heat from bouncing back to the ship. This was the first major step. It proved that old ways of building pads would not work. Here's how they actually did it. They also added a water-cooled steel deck. Water flows through it during engine start. It acts like sweat on skin. It pulls heat away. It protects the pad. That upgrade is for Block 3 Starship. Block 3 means stronger ships and more engines. More engines mean more fire. More fire means the old pad would not survive. That rebuild took months. Heavy cranes lifted sections that weighed over 200 tons. Welders worked in Gulf heat. Pumps were added, pipes were run, tanks were placed. Every change aimed at one thing: let the pad survive repeated launches, not one. Many. That's the shift from test site to factory floor. You've seen this kind of build before when you build a shop to last for years. You don't nurse flaws, you cut them out. SpaceX didn't wait on Pad A alone. They started Pad B. OLP-2 sits southeast of Pad A. You can walk between them in minutes. Pad B has its own tower. It has its own catch arms. Those arms are built to grab the booster when it falls back. That means the booster does not land on legs. It gets caught by the tower, saves weight. That weight turns into more cargo. Pad B was designed with Pad A's scars in mind. The base is thicker, the water system is larger, the steel deck is stronger, sensors cover it, cameras watch every inch. This pad is built for faster rhythm, roll out, fuel up, launch, catch, clear, then do it again. This is the pattern of victory. Early 2026 is the target for first launch from this pad. That's not far. Steel already stands. Arms already hang. Systems are being wired now. And this is where it gets interesting. 2 pads in one place do more than double out. They change how work flows. 1 pad can launch, the other can reset. 1 can be under repair, the other can fly. That cuts downtime. Downtime is the real enemy. Rockets don't earn money sitting still. Because of this, Starbase becomes a production launch site, not a test range. That's why both pads are being hardened. They are being treated like tools, not art pieces. Tools are meant to be used hard. You see where this is going. Texas is only half the story. Florida is the multiplier. The first Florida pad sits at Kennedy Space Center, Launch Complex 39A. This pad once sent Apollo to the moon. It later sent the space shuttle. Now it's being turned again. A full Starship tower already stands there. It's been there since 2022. For a time, work slowed. Other projects took priority. That pause did not mean cancel. It meant sequencing. Work resumed in 2025. Crews came back. Steel was reinforced. The mount was checked. Pipes were replaced. Power systems were upgraded. This pad is being readied for full Starship operations. That means stacking a 400-foot system. That is about as tall as a 40-story building. That means fueling with millions of pounds of liquid fuel. fuel. That means clearing the old systems that once served much smaller rockets. The location matters. LC-39A sits on Merritt Island. It has direct ocean access. It has rail. It has road. It has decades of support buildings. That cuts setup time. It also sits near major tracking systems. Florida already hosts dozens of launches each year. That means airspace systems are used to it. That matters for approval speed. You see where this is going. Texas builds, Florida flies, the Gulf and Atlantic split weather risk. If storms block one coast, the other may still fly. That alone increases yearly launch count. SpaceX did not stop at one Florida pad either. They went north. They chose Cape Canaveral Space Force Station. They chose SLC-37. This site once launched Delta IV rockets. Those rockets are gone now. The land was open. The location is strong. It sits close to the coast. It sits near fuel lines. It sits near control rooms. Here, SpaceX is building 2 Starship pads side by side, not 1, 2. They are called Pad 4 and Pad 5 in planning. The layout changed from early ideas. The pads moved west on the site. That move made room for larger fuel farms. It also reduced conflict with other launch paths. Pad 4 is the first rising. A massive crane, the LR-13000, was brought in. That crane can lift over 3,000 tons. It's one of the largest land cranes on Earth. You don't bring that unless parts are huge. Crane has been placing deep foundations. Concrete pours have reshaped the ground. Tank areas have been graded. Steel for the first tower has been staged. Pad 5 will sit beside it. Plan calls for 2 towers near 600 feet tall. Each tower will have catch arms. Each will have water systems. Each will have full fueling lines. Together, the 2 pads are designed to support up to 76 launches and landings per year. That's about 1.5 per week. From one site, let that sink in. 76 operations from one complex. That's not test pace, that's airline pace. This is where past limits show. Old heavy rocket pads were built to fly a few times per year. 10 was busy, 20 was extreme. They cracked, they aged fast. Crews would spend months fixing flame trenches. That made launch schedules soft. SpaceX watched that happen for decades. They built these pads with that in mind. The water systems at SLC-37 are larger. The steel decks are modular. Sections can be swapped. Pumps are redundant. If one fails, another starts. That means the pad can recover faster. Recovery speed is as important as launch power. Now, here's the part most people miss. 5 pads do not just increase total launches, they change test strategy. They change how fast upgrades reach flight. One pad can stay on older setups. Another can be modified. One can fly Block 2. Another can try Block 3. That parallel work shortens development cycles. 3 months matter in rockets. Sometimes weeks. When one design waits on one pad, progress crawls. With 5 pads, progress fans out. This structure also changes risk. If one pad is damaged, 4 remain. That keeps programs moving. That keeps contracts alive. That keeps crews working. That stability attracts customers. Customers care about schedule more than almost anything. There's also a human side. Each pad has its own teams. Each builds pad-level skill. Those skills stack. People learn faster when they do more. Mistakes happen. Then fewer, then none. That curve is already visible at Starbase. Pad A's scars shaped Pad B. Pad B's lessons will shape Florida. Think about the coordination, fuel delivery lines, power grids, control rooms, fire crews, weather teams. All of it scales with pads. SpaceX is building a small city around Starship. Cities create momentum. Momentum is hard to stop. Now it gets good. These pads are not being built for today's ship. They're being built for what Starship is becoming. Block 3 will be taller. It will use more engines. It will move more fuel. It will carry more cargo. That means ground systems must overbuild now. If they don't, every upgrade forces rebuilds. Rebuilds kill speed. At Starbase, both pads are being fitted for those future loads. The flame trench at Pad A is cut deeper. The water-cooled deck spreads heat wider. Pad B's mount is spaced for stronger thrust frames. The towers are designed to accept larger arms. These details mean the pads will not be obsolete next year. Florida follows the same logic. LC-39A's tower was built tall from the start. SLC-37's towers are even taller. That gives margin. Margin is breathing room. Breathing room keeps operations smooth. You've seen what happens without margin. A system runs hot, parts wear faster, repairs stack, delays grow. SpaceX is trying to avoid that curve. There is also the transport side. Starship vehicles are built in Texas. Florida needs them. That problem pushed SpaceX to develop sea transport for full-size ship. A 260-foot barge is being set up. It will move ships from the Gulf to the Atlantic. That is how you feed the Florida machine. It turns a local project into a national network. Think about the numbers. SpaceX flew 96 missions in 2023. China flew 67 total. Russia flew 19. The Falcon 9 has landed over 250 times. No other rocket has landed once and flown again. The gap isn't closing, it's widening. That is not hype. That is the schedule. By the time others catch up, SpaceX will have 5 pads running hot. That is strategic positioning in steel. This answers a common worry. Can Starship really fly often? The engines are one question, the heat shield is one, the pads are another. 5 pads answer that last one clearly. They are betting on high use. You don't build this much ground for 10 flights a year. You build it for dozens. And when dozens work, hundreds follow. This is where it all converges. Technical mastery, competitive position, strategic future, all in steel. By the time all 5 pads are active, SpaceX will control one of the largest heavy launch ground networks ever built. That network will support testing, cargo, crew, and deep space missions. It will spread risk. It will compress timelines. It will feed learning back into design. The impossible part was never the rocket alone. It was building the environment that lets that rocket work again and again. Here's another reveal. The SLC-37 plan includes room for storage of multiple ships. Not one, several. That means a booster can land, a ship can land, another stack can roll. Parallel work starts. This base is not built for one launch. It is built for flow. Flow reduces cost. You felt this moment before. That point when a project stops being talk, when parts start showing up, when steel starts stacking, when the place changes shape. That's what Roberts Road became in late 2025. You felt this kind of build when you wire a shop before walls go up, when you run pipes before concrete sets. You do it early because later is pain. SpaceX is doing the same. Elevator rails are already inside. Stair landings are already inside. Safety rails already inside. That saves weeks later. It also saves risk. No crews hanging outside at height. No extra cranes. This is resource use through planning. That is not a small shift. That is a launch rate shift. That is how you move from tests to service. This is why the tower matters more than it looks. It is not a photo prop. It is the heart of the flow. You already know this. Factories don't run without docks. Pads don't run without towers. And this one is being built to run hot. That sets the future picture. With Starbase and Florida both able to stack, SpaceX can run parallel test lines. One site tests new ships, the other runs missions, or both run missions, or both test upgrades. That flexibility is strategic weight. It means storms at one site do not stop the program. It means range issues at one site do not freeze launches. It means learning doubles. And learning speed beats raw money every time. NASA's SLS pad cannot do that. That program cost $4.1 billion, enough to build 8,000 schools. It launches once a year at best. Each stack takes months. Each change takes years. Boeing's Starliner pad work has stretched across seasons. Crews wait on fixes. Hardware waits on approvals. Those systems are not. This one is, and that is not hype. It is steel on the ground. 9 modules, finished, waiting. Let that sink in. No tower in pieces, no steel trickle. A full tower already born, just not standing. The moment foundations are signed, the skyline changes. That moment is coming. And when it does, LC-39A becomes a Starship pad, in fact, not name. The arms will rise, the rails will shine, the first test lifts will run, the first dry runs will follow, and then the first Florida Starship will stand there. That is the payoff. The build at Roberts Road shows how this program now moves. Problems are met early, designs reset when needed, systems are built as products, not projects. That is how you turn something that used to be slow into something that moves. And that is what this tower really shows. A program that learned, a team that repeats, a system that scales. SpaceX has 9 tower sections ready at Kennedy. They are built, they are outfitted, they are staged. Stacking is next. When that starts, progress will not be measured in years. It will be measured in weeks. And once the tower stands, Florida becomes a full Starship site. That unlocks a higher launch pace. That opens the next phase. And it confirms something you already felt. This program is not slowing. It is setting up to run. The ground is the part nobody cheers for. The pad takes the hit, the pad eats the fire, the pad either survives or shuts everything down. You already know this. You've watched launches scrub for weeks over pad damage. You've seen teams rush to fix steel and pipes. You felt that slow drag after a big blast. That's why this change matters. The new Starship pads are built to take the heat and keep moving. One test saw frost form in the wrong place. A sensor caught it. The team traced it to a thin spot. That spot could crack in orbit. They replaced the whole ring. Not patched. Replaced. This is the magician at work. That's the kind of call you make when you're building for repetition. You don't nurse flaws, you cut them out. This is where the mission becomes a machine, not a stunt. Artemis needs one success. SpaceX needs dozens. Their business depends on it. Starlink launches need flow. Defense launches need flow. Moon missions need flow. Mars needs flow. One system serves all. And then there's time. NASA's own reports talk about fuel slowly warming and venting over weeks. That's why they plan more tankers. But SpaceX has been testing longer stays, more insulation, better sun pointing, active cooling. Each test cuts the loss. Each cut lowers the tanker count. But here is where the pressure shows. Artemis timelines depend on tankers. NASA wants fuel moved in orbit. That cannot happen without many launches. That cannot happen from one pad. Windows are tight. Moon windows, Mars windows, weather windows. Florida adds options. It shortens gaps. It increases shots on goal. That is technical system mastery turning into schedule control. And this is where near misses enter the story. In late 2025, one Florida tank test ran long. Crews waited, pressure held, then a valve lagged. This is how you learn. 30 seconds from abort, it seated. The test passed. That sounds small. It is not. That valve is part of the main fuel feed. If it sticks on launch day, engines starve. That test forced a redesign, new seals, new sensors. That redesign now flows into both sites. This is why Florida waits on Texas. Texas breaks parts. Florida inherits fixes. The pad that once sent men to the moon may soon send ships that refill others, and that is a different role. That is infrastructure for infrastructure. It is the quiet side of exploration. You see the scale now, but it is the side that makes it last. By the time the first Starship stands, years of unseen work will already be done. Underground lines, load paths, software links, safety loops. That is why mid to late 2026 matters. The road into Cape Canaveral feels the same at first. Low trees, flat land, wind off the water. Then you see it. 2 towers rising together, each one about 600 feet tall. High pace makes errors more likely. People get tired, machines wear, parts crack. The only way to survive that is to build room for error. Redundancy does that. 2 pads, 2 water plants, 2 fueling farms. This is how you win the long game. This site was not built to host history. It was built to produce it. 2 towers, 1 rhythm. A launch site designed for a future where heavy rockets move as often as cargo planes. That future is not here yet, but the ground for it is. and that ground sits on the north end of Cape Canaveral. Progress has been fast. This milestone brings us closer to a monthly launch schedule. Each new tower unlocks more power for the missions ahead. This confirms the new path for spaceflight. The first orbital launch from these Florida pads is coming soon. That will mark the end of the test phase and the start of a new era. This is the ultimate capability.